Hello friends, my name is Heisal Jaison and I am from NTTF Trichy. Today, let's talk about variable frequency drives. So it is also called as VFDs. Then before going to variable frequency drive, we can talk about AC motors. In AC motor, the speed of the AC motor is controlling very difficult. So for that, there was an equation for it. It is Ns equal to 120 F by S, which is which is mentioned in the below side, that is ns refer to the synchronized speed, f is referred to the frequency, and p is referred to the number of poles. As we can see in this equation, the ns is directly proportional to the frequency, and the poles, the number of poles inside the motor, which is indirectly proportional to the motor, or indirectly proportional to the speed of motor. So this method is used for the in VFDs. So what is VFD? A VFD is a type of motor drive, AC motor drive, which is used to control its speed and torque. Both the speed and torque of the motor is controlled by the frequency, which is given to the motor. So it is also called as, it is only mainly having two names, which is adjustable frequency drive and which is adjustable speed drives. So, and let's talk about the benefits of VFDs. So one and main benefits of the VFDs are its first and main benefits. As you can see in this downside picture, it is showing about the energy saving and efficiency working. So first and best benefit of the VFD is that it is saving up to 90% of the energy, and it is also working efficiently. And the next benefit of the VFD is that uh, as you can see in downside picture, the VFD is connected to a motor, and it is connected to a motor. Here VFD is connected to control the speed and torque of the motor. As you can see, in different purpose, we need to control the speed and the torque. So it can be used for the connections for that purpose and all. Then next we can talk about the block diagram. So the block diagram of the VFD is very simple, mainly three to four blocks. So the input is AC and the output is fed to motor. So you can see in the downside there are three blocks in mainly, which is rectifier, DC link, and it is inverter. And there's a down control circuit which is used to control the pulse or frequency of the DC or inverter AC. So first the AC is given input to the VFDs. So the rectifier is converting AC into DC, and there is one problem. When the rectifier is converting this DC, there will be, it is a pulsating DC. It is, we will not get the pure DC waveforms. So we are using DC link box. It is a bank of capacitors and inductors which is used to purify the wave. Means a straight waveform we will get from that, which is used for, which is user to give supply to the control circuits and inverters. So when the last and final part of the VFD is that it is converting DC to AC. So here, when it is converting to DC to AC, the frequency is varying. So the control circuit is varying the frequency by providing a pulse, and also it take feedbacks. As you can see in downside, the bottommost column of the block diagram is like control circuit, and it is, there's a bidirectional arrows. One is for giving and one is for retaking. The retaking is that feedback of the control system, means it will control circuit, it will take the frequency and it will produce the output for working more efficiently, and it will be more accurate. And then there is a one image for that. It's a real-time image, and it is used in three-phase motors or three-phase connections. In that you can see there is a bridge rectifier used in that downside, the blue sheet, it is there. So bridge rectifier is used, which is 6 diodes, which is used to convert it into DC, pulsating DC. And you can see the DC bus or capacitor bus, which is used to purify DC to straight form. Then it is again converted to in AC, but there is slight change. The controllers are used to decide, or controls are deciding the frequency of the AC. Here's the twist is happening. Here where the motor speed is controlling. So if controls are providing a pulse, in that pulse only the AC waveform will be provided, or the frequency AC will be fixed. Means we can change that frequency. then there is a small definition or small definition for how it works. So as I said earlier, a frequency drive is that take AC as input. So it take AC input and there is a rectifier box first itself which convert AC into DC. It's a, I said already, it is giving us a pulsating DC. So we need a purified, means a pure, we need a pure DC for the equipments for working. So we are using DC link. The DC link is a bank of capacitor which is mentioned in the below. As you are reading, it is a bank of capacitor and inductor which give a pure sign, pure waveform of DC. It's a straight, if you are checking in CR. Then it laterally converts into ACs at different frequency. So as you can see, the frequency of the output AC can be verified and it can be fixed. Then if we can go to next, which is a type of VFDs. The VFDs are differentiated into mainly three types based on the output of the its AC output. So there are three types of inverter. So in that three types only VFDs are differentiated. As you can see in downside, the three things are came. So it is about voltage to voltage source converter, current source converter, and pulse width modulation. It will be in a corner of this one. Then that are the main three types of VFDs. Laterally, you can see about the applications, the application of VFD. First of all, the main application of VFD is where the converse. In converse, you can as the GIF shows, the converse rotating is more slow. So if you are not connecting a VFD, the motor will be rotating its own speed and it will be not correct. So you, by using the VFD, you can control it. Smooth means you can get a soft and smooth speed in that and without any jerk. So you can use it for the conveyor systems. And next one is the hoist. In the hoist mechanism, just see the GIF below. Just take a look of that GIF. So you can see that the two motors. There are two motors, and it is pulling together. If you are using separate motors in a separate way, so there is a little problem. Means when you are giving power to it, it will move in a zigzag way because each and every motor is not same because there will be any tolerance or difference. So the lifting of load will be in a zigzag way, which can be dangerous to people who are surrounded and can be also hazard to that load. Then we can see next about pump. In this pump, you can see more than one applications. The application of this thing is that you can see that motor is coupled with the pump. So the speed of motor is directly equal to the speed of pump. So when and you can see that the microcontroller is there and HMI panel is in the top side. Okay, downside in the picture you can see that it will be in the top side. So it is showing that the speed of set point. It is a speed at which I need to rotate this motor. So it is a 1500 RPM, but it is giving a feedback that the motor is rotating it. So it is a nearly approximately 1480 RPMs. So as you see, if I need to 1500, I can adjust it and I can take the speed of the motor approximately accurately. But there will be a little tolerance. Then we can go about advantages and disadvantages of the VFDs. In for every product there will be advantages and disadvantages. So let's talk about this one. Here, first and most important advantage of the VFD is that it save energy. It means energy saving. So the energy what all we are giving in the VFDs, it is approximately, I will say, for example, if I am running a motor in low RPM, the I can save up to 90% of energy that it is running a normal constant speed and I am reducing into gears, reducing the speed by gears. So I can save energy through like that. Then next advantage is that it's fully adjustable speed. In here, the frequency of the motor, the speed of the motor is varied. Means at last you can see the GIF of the motor that it is the speed can be varied by giving the frequency. Means if I am varying the frequency of that, or I am varying the input frequency, the speed can be varied. Then the next advantage of PLC, next advantage of VFD is that dynamic torque control. VFD, normally you will think that VFD is only controlling for the speed, you know, The VFD is also used for controlling the torque also, as well as the applications. Means where a torque is needed, we can control it. Means the torque is important. Somewhere the speed is not required, but we need more torque. Like I say, the hoist, in the hoist mechanism, we need more torque. And next advantage is that high power factor. VFD is having high power factor. As you can see in the downside picture, the more the juice is containing more and the bubbles are small. It is referred to VFDs also. The energy what we are giving or a minimum waste, it is using everything. So it is having more high power factor. Then we can another advantage of VFD is that it is more versatile. Okay, if you are having a VFD, you can fix it with a PLC or another microcontrollers, and you can also use VFD in both AC and as well as DC. It is also main important factors of VFD. Also, you can use it in AC and DC as well. Then we can talk about disadvantages. The disadvantages of the VFD is cost. The one of the main disadvantages of the VFD is that cost. Normally, every means which are having more advantages, it will be more costly. So here, 1 HP motor is having 1 HP single phase VFD motor driver. It is cost around 10,000, so a little bit coster according to Amazon. So another next disadvantage of VFD is that it is environmental concern. So I think you all know about the environmental concern. It's like can keep a VFD just like in outside or somewhere other places. So it can be affected with the rains and heats. And also it should be protected from the airborne particles like cotton threads, etc. Cotton threads, etc. So we are using a VFD panel box. Then the last and main disadvantage of the VFD is that it needs supply harmonics. So the supply, first of all, what is harmonics? Harmonics are the distortion in the waveform, input waveform. So for example, I given in the downside here, the second picture, it is a sine waveform and there is a distortion in that waveform. So it refers to that the waveform is not pure, or it is not a pure sine waveform. So this why I am using a supply harmonic kit or a harmonic filter, because the harmonics can defect the electronic components or a sensitive components inside that. So the harmonic filters are fixed apart, means the input AC lines for filtering, and it will filter and allow the harmonics to pass low impedance path. So I hope you will understand my topic. Thank you. Have a nice day.